I would like to express my gratitude for each of you for joining us today. The focus of my presentation today will be petrogenesis of the Merensky Reef, the largest platinum group element deposit in the world. The Merensky Reef of the Bushveld complex is a stratiform horizon of almost dominantly pegmatoidal pyroxenite. The package pyroxenite is hosted by feldspathic rocks, is usually pegmatites, as far as I'm concerned, and they are bounded by lower and upper chromatite seam in an idealized section. There are other features along the strike known as wide reef and contact reef. In contact reef, lower and upper reef are stacked on one another. In a wide reef, upper and lower reefs have been separated from each other by normal pyroxenite, which is why it's not economic for mining. The Merensky Reef is renowned for its enrichment in platinum group elements, and also is often celebrated for its regularity, remarkable regularity along the many kilometers of strike. This so-called regularity has led to the belief that its geochemical character were controlled by primary accumulated processes in the context of big tank of melt. However, in this study, we have shown that this is not the case. We have documented kilometer-scale lateral variation in these pegmatites, and we showed that Merensky Reef is not geochemically, texturally, or isotopically regular or consistent along the strike. We suggest that secondary accumulated processes such as lateral flow of a melt would be a much more viable explanation. These are the evidences that we put forward, and including geochemical evidences, mineral chemistry, textural evidence, and isotopic evidences. We have presented new petrological rock chemistry, mineral chemistry, and institute clays from the Merensky pegmatites, and also their host normal pyroxenites from Royal Bafokeng platinum mine in the western limb of the Bushveld complex. And we took 4 drill cores spanning 10 kilometers apart in the Royal Bafokeng. We did probe analysis on orthopyroxene pelagic clays of about 1,000 points analysis and 31 sections from all rock types from UG2 up to the Bastard Reef, but the main focus of the study is on the Merensky unit itself. Okay, back. Now I'm going to explain all of these evidences one by one in the following slides. Now let's delve to the evidence starting with mineral chemistry. First of all, orthopyroxene MG number become more primitive towards southwest of the Merensky Reef and pseudo reef pegmatites towards southwest, as you can see here. These are drill cores from northeast and drill core from southwest for Merensky Reef and for the pseudo reef. There are very large lateral variation in AN content of interstitial pelagic clays from 45 here to 77, and the variability of AN content is much higher in this sample from northeast, as you can see. Olivine forsterite become more primitive along the strike. The pegmatoidal rock about 78 to 80 for 2 samples from northeast to southwest, 4 kilometers apart. And also the textural evidences that we have is the peritectic olivine orthopyroxene textures, and also orthopyroxene neoblasts with reverse zoning between these pyroxene megacrysts, and also the orthopyroxene megacrysts. They show evidence of rotation. So these are all clear evidence of dynamic recrystallization that only could happen by either volatile or melt percolation. And melt percolation for the peritectic reaction are responsible for the petrogenesis reaction is trimicris and which produce these neoblasts. We suggest that a hot reactive melt intruded into the pyroxenitic mush, rotated autopyroxene grain and passing through pyroxenitic, the porous pyroxenic mush. Now let's explore the variation of strontium ratio of plagioclase. The interstitial plagioclase of the Merensky normal pyroxenites show strong heterogeneity along the strike. There are systematic decrease in strontium values from northeast to southwest, and this decrease is similar but not as pronounced as the Merensky Reef itself. It might be due to the percolation of melt responsible for the formation of Merensky Reef that has been percolated into their host normal pyroxenite. There are also intra-grain heterogeneity in individual samples from all rock types of Merensky unit. As you can see, the normal pyroxenite and also the pegmatoidal pyroxenite. For example, for the Merensky pegmatoids, there are large intra-grain heterogeneity in plagioclase samples from drill core 1 from 0.7070 to 0.7080. And for the drill core about 4 kilometers farther in southwest, the range of strontium is much lower, about 0.001 and lower, and it's about 0.7060 to 0.7070. These are the same two samples from drill core 1 and 2 4 kilometers apart from northeast to southwest. The intra-grain heterogeneity that we talked about resulted in highly regular zone plagioclase lasses. And they are interestingly consistent with AN content of plagioclase. As you can see, for example, the AN content of plagioclase varies from 82 to 37 from core to ring with an anomaly of 85 near the core. And this anomaly is consistent with high strontium ratio that is shown here in yellow. And also we have talked about the evidence of peritectic reaction in these cumulus autopyroxene, but we suggest that this has been formed during peritectic reactions induced by injection and mixing of a contaminated hot melt into interstitial liquid within the mush. But what could be the reason for this heterogeneity? These isotopic heterogeneity are in fact footprints of mixing of interstitial B1-like, which is shown in blue, and a fresh B2-like, which is shown in yellow, and which is highly contaminated melt. And they mix and produce a mixing product in green here. Such a mixing enhances mineralization by upgrading sulfide. For example, in northeast, we can see P2-like signature, which is highly contaminated in yellow here, and a lot of signatures from mixing products, which the mixing can cause sulfide liquid upgrade and subsequent mineralization in our vehicle to the northeast. On the other hand, in the southwest, we see almost B1-like signature, which is also textural interstitial, and there are also footprints of the hot hybrid mixing products that also here result in partial remelting of cumulates. But mixing here is not as effective as we saw in northeast. So there's no sufficient sulfide upgrade that happened here. So in overall, the reason for systematic variation in mineral chemistry and strontium ratio is that drill core 1 was closer to the feeder in northeast in respect to the others. So these rocks have been more time to become more contaminated and evolve in respect to the other distal trunk feeders. This is the petrogenetic model that we suggest. We have pyroxenitic seal as autopyroxene chromite plagioclase slurries that are placed into the noritic mush, and then we have formation of top and bottom reef packages by injection of a new melt at the base of the pyroxenitic mush, Then we have production of separated hybrid melt by magma mixing, enhanced annealing process to form the pyroxenic pegmatites. And finally, we have the intrusion of autopyroxene slurries within the previous seal by interaccretion, which is causing pegmatites to bisect and producing vertically separated top and bottom reef proximal to the feeder known as the wide reef. So we have wide reef here proximal to the feeder and normal reef, and then contact reef distal to the feeder. So in conclusion, Merensky Reef is not geochemically, texturally, or isotypically regular along the strike, and microstructure, mineral chemistry observation include dynamic recrystallization and isotopic kilometer scale isotopic or chemical variation. All of these are consistent with the flow of the reactive melt. And this is the conceptual model that is my understanding for single compartment of fluorescent layers here. We've shown that here we have the evidence of inclusion of melt into the mesh, and I've already in my previous work showed that there is a possibility of inclusion of mesh into the melt. And so I suggest that the compartment composed of mesh with some transient melt length, similar to the sheeted and sealed model of the ocean. Thank you all for your attention.
He's online.
So. If he's online, we have time for one question.